now we will discuss the solution with explanation of assignment 5 and 6. We have already explained, we have already given the solution of assignment 1, 2, 3 and 4, and also we explained about the solution of assignment 1, 2, 3 and 4. So, let us solve the assignments 5 and 6. So, in assignment 5 you have, it is given that drag polar CD equal to CD naught, which is 0.016 and plus CL is CL square, KCL square. In this K is 0.03 CL square. Weight of the UAV is also given 265 kg. Wing area of the UAV also is given 7.5 meter square, and UAV climbing speed is 35, infinity is 35 meter per second, and it is also given that small angle assumptions, climb angle less than 5 degree. So, in first question you have to find the load factor. First question you have to find the load factor, which is nothing but lift divided by weight. So, at cruise condition lift will be the weight, so it will be the 1 only, but what will be the in climb condition. So, when you are climbing, then your lift will be balanced by W cos gamma. Lift by weight equal to cos gamma, but you know that key angle is given less than 5 degree. So, your cos gamma is approximated as 1 and sin gamma is approximated as 0. So, cos gamma will be 1. So, your answer will be 1. Okay. And in the second equation you have to find the CL value. So, CL value, you are very familiar with this equation, 2W divided by rho V square into S. So, weight is given 265, you have to convert in Newton multiplied by 9.81. Mean sea level density is given 2.556. If it is not given, then take the mean sea level density. V is nothing but 35 and your area is given 7.5. So, your CL will come 0.4617. So, this is your lift coefficient. Second question. So, in third question you have to find the value of CD. So, you know the CD, sorry, in third question you have to find the CD. So, you know the CL, just put the CL in equation 1, you will get the value of CD. So, in third question CD will be 0.016 plus 0.03 into CL, just put CL value 0.4617 square it, you will get CD equal to 0.022396. This will be your CD value. So, in third question you have to find the value of, this is your second question, CD value. So, to get the CD value you have to find the CL value. So, your CD will be the 0.022396 and your third question will be the, what will be the thrust required. So, you know it is already given climb angle is small. So, you can approximate as cruise level flight. So, thrust equal to drag, thrust required, and lift equal to weight. Equation 2 and equation 3. If you manipulate equation 2 and 3, you will together you will get thrust required equal to W divided by L by D. You can also write W divided by CL by CD, right. So W you know 265, to convert into Newton, divided by what is your CL by CD? CL you know 0.4617 and CD you know 0.022396. When you divide CL by CD, you will get approximately 20.615. So your thrust required will be 126.104 Newton. This will be your thrust required. And in fourth question, if the thrust available is given 284.254, thrust available is given 284.254 Newton, then the climb angle in degrees will be, we have already assumed that climb angle is less than 5 degrees. So let us check how much it is coming. So in climb, if you balance the force, so thrust will be nothing but D plus W sin gamma, right. So sin gamma will be T minus D divided by W, right. This is nothing but thrust available minus thrust required divided by W. So thrust available is, it is given 284.254 minus thrust required, you have found out 126.104 divided by 265 into 9.81. So sin gamma is this much. When you take the inverse both side, you will get gamma equal to 3.4877 degree. This here will be the climb angle. Okay, here gamma is a climb angle. So this will be the answer of fourth question. So in fifth question, you have to find the at which rate the aircraft is climbing, means you have to find the climb rate. If you know your velocity vector is in this direction, V infinity, so this is gamma, so this component will be the V sin gamma or V infinity sin gamma. This will be the your climb, rate of climb. So you can denote as a small v equal to V sin gamma. So V you know already, it is given 35 into sin gamma, sin 3.4877 divided by, no, not divided by, so your answer will come 2.12 meter per second. So this is your climb rate, and this is your fifth. In sixth question, you have to find the fuel fraction, and from 1 to 5 the data is given, and from 6 to 10 other data is given. So you have to use that data in order to get the answer from question 6 to 10. So let us write the data which is given. So first this equation is given, total weight of the aircraft air vehicle is nothing but weight of the avionics, can write W avionics, W subsystem, W propulsion, propeller, W propulsion system bit, W other, W structure, W payload, W fuel or energy. So, no, in aircraft payload will be there, fuel will be there, propulsion system will be there, structures will be there, your avionics software and all, this will come into this, your hydraulics and all will come in this, W others, bags, extra things you can take in this W others. With this information, it is also given mass fraction of structures, ki how much percentage with respect to the total aircraft weight the structure weight is given 0.051, and your power to weight ratio of air vehicle is also given, which is 0.13245 HP per kg, and brake specific fuel consumption is also given. To B, I am writing brake specific fuel SFC, specific fuel consumption is 0.13245, and mass fraction of propulsion system, which is 0.05, L by D max is also given 12 at cruise condition. Propulsive efficiency is given 0.65, and maximum range is also given 6385 kilometer, and it is given that all avionics, W avionics, payload and other having weight equal to 50 kg, means W avionics plus W payload and W others is equal to 50 kg. W subsystem, W propulsion system, W structures, W fuel. If you divide it by W takeoff, you will get mass fraction of propulsion, which is given, mass fraction of propulsion which is given. W structures divided by W takeoff, mass fraction of the subsystem is given, okay, and mass fraction of the fuel, W fuel divided by W takeoff, you have to find. So, suppose that we know the W fuel by W takeoff in this equation, then we can get the takeoff weight. So, everything we know, what we want to know, that W fuel divided by W takeoff. So, UAV is given, okay, R max is given. So, you know that ki if you know the R max equation, range is given. So, you know the UAV, most of the UAV is propelled power, right? So you can use the range formula in order to get the mass fraction of fuel fraction of this system. So using this formula, R equal to eta PR divided by C. C, this is a brake specific fuel consumption, which is given 0.13245 HP kg per HP hour, right? This is kg per HP hour. Okay. So you can use this formula, L by D ln W naught divided by W1. W naught is the weight when all the fuel will get consumed, and W1 is the initial weight. This makes it a W1 and this is W naught. So W naught is a total weight of the air vehicle and W1 is a weight when all the fuel get consumed. So R max is given. So if this will be the maximum, then this also will be the maximum. Okay. So you just put the value of R max, which is given 6385 meter to kilometer, so you have to convert into meter. Propulsive efficiency is given 0.65 and C value is given in kg HP hour. So here you can write C equal to what is given 0.13245 kg per HP hour. So this thing you can convert into SI unit. So what you will get 0.13245 into 9.81. You have to convert into Newton divided by 1 HP equal to 746 watt, and hour if you convert into minute, this will come 60 minute into second, again the 60 will come. So if you finally will get this unit as a 1 by meter. Okay. So this value will come out 8.273626 into 10 power minus 7 per meter. Okay. So you can put this value 8.273626 into 10 power minus 7. L by D max is given 12. So ln W1 by W naught. So you have to take at least 5 to 6 digit in order to get the correct answer. So what will be your W1 by W naught? It will come 0.5080. Okay. So this is W naught and this is W1. Okay. So first you will get, if you rearrange this, you will get W naught by W1. If you reciprocal this, you will get W1 by W naught, and we know that W1 is nothing but total weight minus weight of the fuel, because already I told you that W1 is a weight when all the fuel get consumed, into 0.5081. So if you divide, if you take this term separately, WF by W naught, you will get WF by W naught as 1 minus 0.5081, which will come 0.4919. So, this is Wf by W naught. So, you can say this is a mass fraction of fuel. Okay. So, you can use this formula in order to get the mass fraction. So, in first question it is asked to find the value of fuel mass fraction, which is coming 0.4919. In the second question you have to find the total takeoff weight. So, see this these things and this, if you combine W avionics, W others plus W payload, it is given 50 kg, and this in terms of mass fraction ratio, this in terms of mass fraction ratio, this in terms of mass fraction ratio, and this in terms of mass fraction ratio you got. So, this equation if you manipulate, then what you will get? So, you can write W takeoff these 3 first. So, this will be W avionics, first you write these 3 which is given, W avionics plus W other plus W payload, this you write separately, and next is W subsystem. So, W subsystem you can write W subsystem divided by W takeoff into weight of the takeoff, okay, plus W propulsion you can write W propulsion divided by W takeoff into W takeoff, plus W structures you can write W takeoff into W takeoff, plus what will be the last? W fuel, that W fuel divided by W takeoff into W takeoff. So, this is mass fraction of propulsion system, this is mass fraction of structures, and this is mass fraction of subsystem, and this is mass fraction of fuel, okay. So, bring this and this term in this side. So, what you will get? W takeoff will be the common, then 1 minus mass fraction of subsystem again you can put one bracket plus mass fraction of propulsion system, not propeller, mass fraction of structures plus mass fraction of fuel. So, you can create this bracket, this, and equal to W avionics plus W others plus W payload. Let us make it X, okay. So, you can write W takeoff separately as W takeoff equal to X is nothing but 50 kg, it is given W avionics plus W others plus W payload 50 kg divided by 1 minus mass fraction of the subsystem, which is given. Mass fraction of the subsystem is 0.051 plus mass fraction of the propulsion system 0.05 plus mass fraction of the structures 0.051 plus mass fraction of the fuel, you got 0.4919. Okay, let me check 0.05, 051, 0.26. Mass fraction of the structures is given 0.26. Okay, so 0.26, 0.49, 0.051, 0.05. Okay, and this is 50. So your W takeoff will be 339.9048 kg. This will be your answer. And in next question you have to find the weight of the power plant. So one relation is given to you, that mass fraction of propulsion system equal to P by W takeoff of air vehicle divided by P divided by W power plant. So this P will get cancelled, W takeoff you already know, mass fraction you already know. This is nothing but 0.05. If you put W takeoff is, which is coming 339.9048, you will get the W power plant equal to 16.9952 kg. This will be the answer of your 8th question. So in 9th question you have to find the peak power of the air vehicle. But the engine, what is the power, maximum power that engine is having? So P by air vehicle is also given 0.13245 HP per kg, it is given to you. So multiply by W takeoff, you will get P equal to 45.0239 HP. This will be the answer of your that question, which is question number 9. So suppose that with this power the UAV is flying, then what will be the speed? In next question you have to find that. So you know power required is nothing but thrust required into velocity, and you know thrust required is W takeoff divided by L by D at cruise condition. Okay, and if your power required and power available is equal, means power you are flying with maximum power, which is here 45.02, which you have found out. So put this peak power 45.0239. This means you are flying at a maximum power, you are using maximum power from the engine. So this is HP, you can multiply by the watt, you will get the answer in watt. W takeoff you have found already 339.90 into 9.81 to convert into Newton divided by L by D is given 12 and V infinity you want. So, V infinity will come from here, your V infinity will come 121.9411 meter per second. So, if you are flying with this power condition, your speed will be the 121.9411 meter per second. So, this is all about the assignments 5. So, last we will go the assignment 6. For an electric power fixed wing UAV with a standard parameter and mission profile is given. So, the mission profile is given to you. So, the mission profile is given to you. Your L by D is 11, your weight is 21548 means weight of UAV, range is 800 kilometer and the speed which is flying, the UAV which is flying at this speed, and hint also is given, means you have to consider the UAV is flying at a cruise condition. So, in this first we have calculated the battery power required. So, what will be the battery power in kilowatt required to complete this mission? So, you know that power required is nothing but thrust required into velocity. Okay. Thrust required, you can write W divided by L by D into V infinity. W is given 215.348 divided by L by D is also given 13. Okay. L by D is given 11 into 9.81 into 30. So, your answer will be 5761.537 watt. So, in kilowatt your answer will be 5.761 kilowatt. Okay. So, this will be your power required 5 point. Okay. So, in second question you have to find the endurance, so that you can easily find endurance is nothing but range divided by velocity. So, range is given 800 kilometer, you have to convert into meter, divided by speed is given speed is given 30 and this is in the, it will come in a second. So, if you multiply divide by 3600 you will get the endurance in hour. So, that will be the 7.407 hour. Okay. This will be the your endurance. And in third question you have to find the total energy in kilowatt supplied by the battery. So, in kilowatt hour. So, total energy will be what you got, the power required is multiply by the endurance. So, power required is 5.761 kilowatt into endurance is 7.407. So, your answer will be 42.675 4 kilowatt hour. So that will be your total energy. So how much the battery will have? If the total energy is this, you want endurance 7.407 and you want range is 800 kilometer, then how much battery weight will be required? So battery weight depends upon the which battery you are choosing, means a specific density is required in order to get the battery weight. So a specific energy of the battery is given. So total battery weight will be total battery weight equal to total energy which is, you got 42.674 kilowatt hour, you can convert into watt hour. Okay, this is unit is watt hour per only watt hour divided by, this is total energy and a specific energy is given 200 watt hour per kg. This watt hour will cancel. If you solve this, you will get 213.33 kg. This is the total weight of the battery. So in the fifth question, what is the necessary condition of the stable UAV? So sir already explained you about the longitudinal stability, significance of Cm naught, Cm alpha. So as you know that from this diagram you can say, if your angle of attack is in x axis and pitching moment coefficient is y axis. So this is your Cm versus alpha graph for the stable UAV. In this condition Cm alpha is less than 0. So this is a necessary condition. In this case Cm alpha is also less than 0, but Cm naught at alpha equal to 0, Cm is 0. So in this condition also your aircraft is stable, but you cannot trim the aircraft at positive angle of attack. Okay. So for answer this question, your Cm alpha will be less than 0. Okay. This is the necessary condition of the stable UAV, but in order to trim the UAV or aircraft at positive angle of attack, your Cm naught should be greater than 0. Okay. And in 7th question you have to find that which condition holds the stable UAV at 0 angle of attack. So to this condition will satisfied Cm alpha less than 0 and Cm naught equal to 0. If you have these two, you can trim the UAV at 0 angle of attack also. And in 8th question, some airfoil is given like airfoil OFA, and last one is the airfoil S1223. So the comparison is given, and x axis the angle of attack is given and y axis lift coefficient is given, and the question is which airfoil will give the lowest stall speed. So see, if you write this CL equal to 2W from lift equal to weight rho v square, if your CL increases keeping all the parameter constant, this S will also come. If your CL increases, then V will decrease. So just pick the airfoil which has higher CL max. So in this condition airfoil S1223 will have the higher CL max. So for that particular airfoil the stall speed will be the lower compared to all. Okay. And in 9th question, a wing is made of symmetrical airfoil. The pitching moment coefficient at 0 degree angle of attack will be. So, you know, for the symmetrical airfoil at 0 angle of attack, the pressure distribution on the upper surface and pressure distribution on the lower surfaces will be the same. So, there will be the no lift at 0 angle of attack. And also, suppose this is a symmetrical airfoil, your net upper pressure, lower pressure acting, let us say PL, and net upper pressure acting P upper. So, this will act at the same point. So, there will be the no lift and no moment. So, in this case Cm equal to 0. Okay. And for the 10th question, for positively cambered airfoil produces, in bracket also given that the leading edge of moment is positive. So, you know that for the cambered airfoil the CMAC is negative. So, obviously it will produce the nose down moment. So, nose down moment is negative. So, it will produce the negative pitching moment about the aerodynamic center. So, this is all about the assignments problem. We have already solved the problem, 10 problems. So, all the best for your exam. Thank you very much.